the goal for the rest of the module is to be able to create a time series of precipitation over the chosen years and do some trend analysis. How do we get precipitation data? Well, the precipitation is often measured on the ground using rain gauges. So you have rain gauges, ground stations, which are measuring rainfall. They are automated ones, there are manual ones, and you get the daily rainfall that is measured from those. These are then aggregated, interpolated, and then you get this gridded precipitation data set. It's important to interpolate because you cannot measure rainfall at every place in the world, right? You can only set up stations at limited places. So if you have two stations 100 kilometers apart, you want to know what happened in between. So you create this regular gridded data set where you have a grid size of 5 kilometers, 7 kilometers, 1 kilometer, whatever size you choose, and then you estimate the rainfall in that grid. And that's why that was the gridded, that's how the data set comes in gridded rainfall data set. There are different types. There are certain data sets which do not use any ground stations. They are purely satellite based. So these are satellites up in space measuring the precipitation on the ground using some indirect technology. So the main data set for this is a mission called GPM, Global Precipitation Mission, which has these two data sets. We'll learn about this in detail. That just looks at the Earth's surface and the clouds and estimates the rainfall based on its algorithm. There are some data sets which are reanalysis data sets. These are the data sets that are based on the weather models. So these are very large weather models which are run based on a lot of physical measurements. So you have measures of temperature and pressure and other variables, and then you run a simulation of what will be the weather forecast. And this is how you get your daily weather forecast. There are many public domain models which are also available. But what happens is, let's say you predicted some rainfall to happen tomorrow. And tomorrow you actually know what happened, right? You get the actual measurement in the future. And you take this data, then you run it again through the model, which improves your model. So these are called reanalysis data, which are run based on the actual ground data plus your weather models, and you get the reanalysis data. ERA5 widely used data set, which is available in Earth Engine, which is a reanalysis data. And there are many such data sets also available. The third one is you take the satellite data and you calibrate that using the ground station data. This is a data set called CHIRPS. We'll learn this in detail. This is what we're going to use for our module today, where we'll take the satellite measurements, they take the ground measurements, and then combine both to get the best of both worlds. Satellite is great because you have complete coverage, and you have, you can have a measurement which is you can fill the missing areas. Ground stations, because they are most accurate. You combine both, you have a really good global data set, which is very accurate. So that's the third type. Fourth type are just ground station-based data sets. Many country level data sets will come like that. You have a network of ground stations in your country, and you just interpolate them and you get the data set. So for India, there is a IMD data, which is available in the public domain, really long, 100+ year time series of precipitation. It's available, and it's not in Earth Engine directly, but I have scripts, etc., that allow you to take this data, convert it, and upload to Earth Engine if you want to use it for your analysis. And again, this may be important for a lot of you that you're working in your country. You want to use your country's own data set versus a global data set. You might say that CHIRPS is better or ERA5 is better, but then if you're working with the government in your country, they trust their own data set more than other countries. So again, there's a way for you to upload them. If you can convert your data set to GeoTIFF files, you can upload it and use it. Let's learn about each of these data sets in detail, so you can appreciate how they do measure precipitation differently and which might be the most appropriate for your analysis. GPM, this uses the passive microwave. So the clouds and Earth's surface, they emit microwave radiation. So it measures that. And also it uses an infrared sensor to measure the precipitation. And it has a model which estimates based on the amount of radiation measured, it correlates that to the ground precipitation. This is a pretty good coverage. So +65 to -65 degree latitude. So if you're working in any of those regions, you'll have a measurement there. 12-kilometer grid resolution, not the highest, but still decent. When you work with climate data are generally not very high resolution. So, your resolution would be pretty coarse, but you get a 12-kilometer grid from resolution. The best part about GPM is it's near real time. You get the precipitation within 6 hours of real time. That means you say there was a heavy rainfall in my region today. 6 hours later, you can actually see that in the data set. So it's used for any kind of prediction, near real-time monitoring, and so on. Also, the temporal resolution is pretty good. You get data for every 30-minute interval. So if you want to say, I want to know, did it rain between 5 p.m. and 6 p.m. 10 years back on this day? Well, the data set would have that information. So a 30-minute interval data set, really good. I used this data set for one of my models. I was working on a project modeling traffic in Indian cities. And in Indian cities, whenever it rains, it kind of creates chaos with the traffic. So I wanted to use the rainfall as one of the variables. And I could say, for every hour, tell me the total rainfall. And you can get hourly rainfall out of GPM for this kind of modeling. One note is you have the GPM datasets. Their goal is to get the information out as quickly as possible. So as soon as the data is available, it's processed and fed to the user immediately. So when you get the data set immediately in Earth Engine and you go to the metadata, it'll say the type will be early. And what happens is, as more information becomes available, there is some other data sets become available, there's some QA happens. A few hours later, you have the late version. So the same data set will be overwritten with the new version. Most often, it's the same data, but sometimes there is some changes in your pixel values because something updated based on the additional processing event. And then a few weeks later, once all the data set is available, correlated, and there's a final version of the data. And that is the most accurate version of data. But again, they don't want to wait till a few weeks to give you the data. So that's available. One of the problems you might see with GPM data is, say, I ran the script yesterday, I ran this today, I got a different answer. Same script. Why? Because the version might have changed. It was an early version yesterday, now it's a late version. Usually there is not much difference, but just note that they are these versions that are released over time. There are two algorithms. So GPM has the source data. So it's a constellation of satellite that gives the input data. How do you process the data and get the results? So the IMERG is one algorithm and GSMAP is another algorithm. So you get two different algorithm outputs for this. And again, GSMAP is available in a similar temporal resolution. So GPM is great where you want high temporal interval. So you want data at high temporal resolution every 30 minutes, every 1 hour, you can use GPM. If you want the data soon or near real time, GPM is great for that. But since it lacks any ground component, the accuracy is not that great as other data sets available. ERA 5, this is a reanalysis data from European Center for Medium Range Weather Forecasts. Again, this is based on a weather model and historic observations. It's global coverage, so anywhere in the world. So if you're outside this minus to plus 65 latitude range, and if you want a precipitation data set, ERA 5 would be a good choice. 9-kilometer resolution, the reanalysis one is 31 kilometers, so coarser than GPM, but it's still there. It's available at hourly, daily, and monthly timescales. Because it's a model, right? It's a weather model, you can say, give me a value at every hour. You can run the model at different scales. It's available after 3 months. So it's not good for real-time monitoring. It's good for more of a historic monitoring. Right? So it's available from 1981 to present and after 3 months of real time. The third one, which we're going to do a deep dive on, is this data set called CHIRPS. CHIRPS stands for Climate Hazards Group Infrared Precipitation. So Climate Hazards Group is a university research group that produces this data set. Infrared precipitation, because it uses the infrared radiometer to measure the precipitation. The S part is important here with station data. So the earlier version of this data was called CHIRP, which is just simply satellite-based measurement. CHIRPS has the station-based data. So it correlates both the station data along with the satellite data to produce this data set. This is the coverage of CHIRPS, much lesser coverage. So if you are outside this coverage area, you cannot use CHIRPS. Most notably, Canada is missing. So if you want to use this data for Canada, you're out of luck. use GPM or ERA5 or other datasets. But it's a 30-plus-year graded rainfall data. So it's 1981 onwards. You have the precipitation datasets. Pretty high resolution, 6 kilometer spatial resolution. It is one of the highest resolution precipitation datasets that's available. Plus to minus 50-degree latitude coverage. And it combines the ground station data. This dataset is, one of the features of this dataset is that it's internally consistent. So again, all these data sets that you use, they are based on some models, so they'll have biases. If you correlated that with your country's own data set, you'll say, oh, CHIRPS in my country always shows higher precipitation than other data set. Or it underestimates precipitation in certain areas. But internally, CHIRPS is consistent. So if it's underestimating for every year. If it's overestimating, it's overestimating for every year. So where would you use this data set? Well, it's great for drought monitoring. It's great for historical comparison, because if you want to do trend analysis, it doesn't matter whether it's what are the absolute errors are. Internally, it's consistent, so you'll get pretty good trend analysis out of that. There's a question on ERA5 covers entire globes. Yes, ERA5 has the full global coverage. And again, you can kind of think about how this is created, right? Satellites can cover only certain parts of the region. For covering the polar region, satellite has to be in a certain configuration. But this ERA5 is just a weather model. It's a model that runs on a supercomputer based on all the parameters. So again, it can run at any temporal interval. It can run everywhere and so on, right? So it's a global weather model that's run. Good question. Does precipitation also include snow? Depends on the data set. CHIRPS only includes liquid precipitation, so only rainfall. Other datasets does include snow, so read the documentation on what kind of precipitation is covered. Right. So CHIRPS dataset is given in this interval of pentad. Pentad is a grouping of 5 days. So when you look at the CHIRPS dataset, you'll get one image for every 5 days. So 1st Jan to 5th Jan, there's one image. That's first pentad. Second pentad is 6th Jan to 11th Jan, and so on, right? So every calendar month has 6 pentad. So you take January 1 to 5, 6 to 10, 11 to 15, and so on. So these are a grouping of 5 days. And you have 5 pentads, which are 5 days. So 25 days, you have 5. And then depending on the length of the month, the final pentad will be 3 days if it's a 28-day February, or 6 days if it's a 31-day month, right? So you have up to 6 pentads in every month, and the pentad will reset at the beginning of each month. So February 1st will be a new pentad. March 1st will be a new pentad. And that's how the data is computed. So CHIRPS will tell you what was the rainfall that happened in the first 5 days. There'll be one value. It'll tell you what was the rainfall over the next 5 days, and so on. So the unit of measurement is over a pentad. Why pentad? That's an odd thing, because the CHIRPS uses some other input dataset, which also comes as pentad. That's how it was done historically. So again, we do not know exactly the distribution of rainfall within those 5 days. You just get the total rainfall that happened in those grouping of 5 days. And since pentad also, you don't really use it for any real world purposes. So when you're using CHIRPS, you'll say, I will create an image for the monthly rainfall or yearly rainfall or whatever time period that I'm working with. So we need to do some pre-processing of this time series to create the unit of length that you are most interested in. CHIRPS is available at a 3-week latency, because once the satellite measurements are collected, it has to wait for the ground station data. It's a global data set, global coverage of ground stations. So once all the ground stations collect the data, process it, they send it to the CHIRPS team, then they apply it. So there's a 3-week latency. So again, not in real time, but it's good enough for doing kind of a drought monitoring or real-time, near real-time measurements of the ground situation. The data set comes in as images with just one band called precipitation. The unit of the pixel values are millimeters of rainfall per pentad. So when you look at a CHIRPS image, inspect a pixel value, it says 5. What does 5 mean? Well, this says this was 5 millimeters of rainfall in this pentad, whatever pentad it represents. And we'll work with this data and compute maybe yearly or monthly product of that. There's a good question that if you search for CHIRPS in your data catalog, let's say, I'm going to go to the Earth Engine and search for CHIRPS. I have two data sets. There's a CHIRPS daily and CHIRPS pentad. Well, you just said that there's only pentad data. So what's going on? Well, the daily data is computed by disaggregating the pentad data. You don't really have measurements of every day. It uses some other data set to estimate what might be the distribution rainfall over those 5 days. So this is the source data. The daily is a computed data based on an estimate of the distribution. Here it says daily products are derived by disaggregating the pentadal product. So use it if you must. If you really need daily data, you can use it. But again, the accuracy of that would not be as high because they are again used by disaggregating the data set.